You've got a skier starting from rest on the top of a large hemispherical hill. Ignoring friction, show that the skier will leave the hill and become airborne at a distance of h equals r over 3 below the top of the hill. Hint, at this point, the normal force goes to 0. So I've drawn below here a much larger one just to make it a little bit easier to visualize. The skier starts out from rest and gains speed as they fall through some height. So what can we immediately do? We can do a little bit of conservation of energy. So mgh equals 1/2 mv squared. No friction, so no energy loss. So pretty straightforward on that part. And we can very quickly get rid of mass, and so we get gh equals 1/2 v squared. And just rearranging a little bit, we can very quickly get that v is going to be equal to the square root of 2gh. Now we're really looking for centripetal acceleration at this point. We have radius and we have velocity, so I'd recommend that we actually solve it using this one, v squared over r, which in this case is going to be simply 2gh over r, just squaring the result we had before. And the centripetal force required, remember that's the net inward force, is just going to be that times the mass of the skier. So in this case, 2 mgh, having nothing to do with energy at this point, over r. Now, the one issue we have here is, what are the forces acting on our skier? Well, there's basically two. There's the force of gravity acting straight downward, and there's a normal force acting on the surface. And you can almost think about this as being an incline. We're trying to figure out at what point this normal force drops to 0. Well, what's actually causing it to drop to 0? Well, if we look at this closely, you could break the gravitational force into its perpendicular and parallel components to the slope. And yeah, you could think about this as being a portion of an inclined plane. And it turns out this angle up here is also theta. So the normal force then would normally just equal force of gravity times the cosine of theta. In other words, mg cosine theta. And that would give us no net force towards the center. Sorry, if you look at this triangle, it's a right triangle. Theta's up here, so this side here would be mg cosine theta. If force of gravity is mg, sorry, I should write that out. But we've got this centripetal acceleration going on. So what's happening here? The normal force has to be smaller than this component down here to produce a net inward force. How much smaller does it need to be? Well, it has to be reduced by that centripetal force, the force that we need. By subtracting this, it means the net inward force is going to be what I just wrote here in blue. Because of that, we can do a little bit of mathematics with this one. We want to figure out when this whole equation is equal to 0. So we can set it equal to 0. At what point is the normal force equal to 0? Well, it turns out when these two quantities are exactly equal to each other. And sorry, it's going to take me longer to write out than it's worth. But you'll see a couple of nice things that happen here. Moving this term to the other side, so 2 mgr, or sorry, h over r, is equal then to mg cosine theta. We get just that 2h over r is equal to cosine theta. And this is the instant then that this whole thing goes airborne, where the normal force drops to 0. But I still have h in here. I need an expression for h over here in this triangle, and we can do that really quick. If you look at this right triangle down here, this is r. So this side over here is going to be just from here to here. is going to be r cosine theta. And since we know this entire distance here is r, we can actually express h. H is going to be equal to r minus r cosine theta. The difference between the radius, we know that's all the way to the top, minus the cosine theta. Or we could also rewrite it as r times 1 minus cosine theta. I'm going to substitute that in down below here. And since I'm in that color right now, forgive me, I'm going to do that first. So 1 minus cosine theta, all times r. Then just substitute that in for h down here. And then going back to the other color, just to be consistent. So 2 times that, all over r, has to equal cosine theta. And now just some math. R cancels, of course. This becomes, just multiplying through, 2 minus 2 cosine theta equals cosine theta. And then just subtracting that from both sides, 2 is equal to 3 cosine theta. Or 2 over 3 is equal to cosine of theta. But we're trying to find height. So what we're going to do, we're going to plug this back into the original equation here. So taking that top equation there and solving it, just taking this one over here now to solve for h. We know that h is equal to r times 1 minus the cosine of theta. But in this case, we know that cosine of theta is equal to 2/3. So I can substitute that in right away. And we discover the height is equal to r times 1/3, or just r over 3. And that is the answer to this one. It'll become airborne, or the skier will become airborne. Normal force will drop to 0 when the height is equal to r over 3. I know, pretty crazy, but doable.